Namaste and welcome to the course of Introduction to Mechanical Engineering. In this course, in the discussion of today's, it will be all about the types of flames in gas welding. So before going into the gas welding, let me come out with what is this welding is all about. Welding is the process, let me make it quite clear, is the process of joining two or more similar or dissimilar materials with the application of heat with or without pressure. Let me say once again, welding is all about the process of joining two similar or dissimilar material with the application of heat with or without the pressure. So in that, this gas welding comes under the process of joining two similar dissimilar material without pressure. Okay. So what all we need for a gas welding? Yes, particularly two cylinders. I said the gas, two cylinder, oxygen and acetylene. If you could see over here, the gas welding, we need a gas in which the two cylinder fills with one with an oxygen, other one is acetylene. Those two cylinders will pass, the gas will pass through the cylinders to the torch, right? From the torch, we would have a flame and we need a filler material in this system. So all the way, we would have a pressure regulator, as I said that, the gas cylinders, two gas cylinders, one is a black color, another one is a red color. The black color cylinder signifies oxygen in it and the red color signifies the acetylene in it, clear? And both the tubes that passes from a cylinder to the torch is the one such place where both gas are mixed up using this, yes, needle walls, right? Whatever the flame that comes from this is this one. And this is very important in the gas welding, the types of flames, because the flame generated over here gives out or to be used for certain applications. So that's a motivator, a point behind to learn what all these types of flames in the gas welding. Okay. So flame, as we know that out of a torch, what we get is a flame, and I need a filler material to weld over here. As I said that it's a process of joining two similar or dissimilar materials. So filler material is the one when we bring it near to the flame, the filler material converts into a molten state and fills over the gap. Once cooled, it gets solidified and thus the welding done, right? Now try to understand what are types of flames we do have. So first one, neutral flame. This is how the neutral flame looks like. Second one, oxidizing flame, and this is how the oxidizing flame look like. And the last one is carburizing flame. Let's try to understand each flames clearly. Okay, first one, neutral flame. Yeah, you can see the sketch over here, neutral flame. As the name itself says, neutral. In this case, the proportion of oxygen and the proportion of acetylene are in equal in ratio, 1:1. So it's a well-defined flame with an inner whitish core surrounded with blue sharp flame, as you could see over here, inner whitish core and whitish core and a sharp blue flame. And in above picture you can see that using a filler material the welding is done over here. In this case, the welding is done in this form. Like as I said that each and every flame has its own application to do. In neutral flame, the welding is done in this form. Let's go for the next flame. The next flame is all about the oxidizing flame, clear? And this is how the oxidizing flame look like. As the name itself says, oxidizing flame. So here, the ratio of oxygen when compared to acetylene is more. Sense out, the oxygen is more than the acetylene in a ratio of 1.15 to 1.5. As the way the flame looks like, the inner white core is shorter and outer envelope being narrow and brighter in color. It's brighter in color in this case, oxidizing flame. And application, very important, as I said that every flame has its own application to derive in. So in earlier case, neutral flame, it is used for welding. In this case, it's not for welding. It's for cutting. As you can see over there, this form of flame is used to cut, not to weld. Why? Because of more in oxygen content than in acetylene. Oxygen accelerates and it cuts the system. Clear? Okay. Now let's go to the next flame, which is a carburizing flame. Again, in the first case, neutral, both oxygen and acetylene, same in ratio. Second case, oxidizing, where the oxygen is more when compared to acetylene. And the last one, carburizing flame. Make a point over here. It is the one where the axis acetylene in and oxygen less in content. Another way, the content of acetylene gas is more when compared to oxygen in a ratio of 0.95 to 0.1. Make a point, boy. Here, the inner white core is an inner part, and the intermediate part we do have. If you compare with the earlier one, here we do have three flames that comes out from there. One is inner whitish cone. The second one is intermediate whitish cone known as a flame feather. Another name is an acetylene feather, which exits between the outer and inner, and the outer envelope is much longer than neutral envelope. If you could remember, the neutral flame do have a bluish color. Here it is much longer than the earlier one. Yes, again the application, yes, very important. As I said that each and every flame has its own application. Like if I could make out a point, earlier neutral, welding, oxidizing is for mainly to cut, not to weld. But here, yes, it's for welding, but not a metal, but let's say alloys, aluminum and cast iron. So as a summary, the gas welding has three flames: neutral flame, oxidizing flame, carburizing flame. Neutral flame, the content of oxygen and acetylene are equal in proportion, same. Oxidizing, the content of an oxygen is more when compared to acetylene. In carburizing, the content of acetylene is more when compared to oxygen. Thank you.